David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, transformation of quadratic functions. So now we're going to start sliding parabolas around and transforming them, changing their shape. So first, let's take a look at vertex form. This is something that you should have had in a prior class. Let's assume prior knowledge. We're going to do a little quick review of that and what it lets us do. So vertex form is some number a, some constant, times x minus h squared, the binomial squared, plus k. And this is called vertex form because the vertex is hk. Notice one thing. There's a minus here. So what that means is that you change the sign. If this is negative 2, h would be positive 2. K stays the same. This is a trick that you just have to remember. Okay, so let's take a look at this in terms of translations. K controls the vertical translation, up or down. So we could write the translation of a quadratic just like 0k. The same thing for h, except it's horizontal. So h controls the horizontal translation. So we could write that h0 if we're just translating in a horizontal direction. So let's take a look at some graphs and see what we get. I'm going to start with the granddaddy or grandma parabola. This is y equals x squared. It's the most simple parabola. And I'm going to take a look at two others, this one and that one. So first off, I'm going to do a quick graph of y equals x squared. The vertex for this one is right at the origin. And then your 2 points that are quickest for sketching this parabola, you know that it goes over 1 and up 1. Because if x is 1, so is y. So I get 2 points there. And then if I go over 2, I'm going to go up 4, which is somewhere up here. Over 2, up 4. Notice how it goes positive because x is always squared. So even when you put in a negative number for x, it's going to get squared. It's going to be positive. So here is a sketch of that graph. Okay, so now if you want, see if you can get these. Here's another one in vertex form, and here's yet one more. So let's see what happens. Pause the video, give it a try. Okay, let's see how you did. Minus 2 means we go 2 in the right direction. Remember I was saying that there's a negative here, so that means switch the sign of whatever number you see. So negative 2 means I'm going to go over 2 and then down 3. 1, 2, 3. So there's the vertex for that parabola. Now using this trick that we did before, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. Roughly speaking, there's our parabola. Now, what's the translation vector for this one? We went 2 minus 3. So that's how you'd write the translation vector for this. In fact, what we could do is we could write y equals x squared 2 negative 3, and that's going to give us y equals x minus 2 squared minus 3. So that's writing this in the translation notation. And you can see, it's pretty much a translation, a slide. We went 2 and then 3 down. And that's where this new vertex went. Same shape. Shape is handled in a different video, and that's controlled by the a term. Let's do that last one. Pause the video, give that one a try. Okay, let's see how you did. So the plus 3 means the vertex is going to move negative 3 over, and a plus 2 means we're going to go up 2. So there's our vertex. Notice how I have a minus sign out here. So that means this parabola is going to open downward. So now I'm going to go over 1, down 1, over 1, down 1. My parabola is like that. Okay? So the second one, we translated it and then we also flipped it. We didn't change its shape. What does a do? So this is the a coefficient in a quadratic function. It shows up in 2 places in both forms of the quadratic function. So standard form, ax squared plus bx plus c. The a is just the coefficient on the x squared term. Okay? In vertex form, f of x equals a times x minus h squared plus k. Remember, the vertex here is hk. this A is the same as that A. Does the same thing, is the same number, okay? So this is a check. If you're converting from standard to vertex form, your A's should be the same when you're done. Okay, so let's take a look at what A does. In some ways, it is the most powerful coefficient in the quadratic function because it determines a lot of things, mainly the shape of the parabola. So I've got 4 conditions here to talk about. I'm going to explain what these things mean. The way we understand what A does is we compare it to the graph of y equals x squared. That's kind of the parent parabola. Every other parabola is a different version of this same parabola. And then take a look at that, y equals x squared. What's A in that function? If you guessed 1, that's right. There is a 1 in front of the x squared. And here's that graph. It goes right through the origin. The vertex is 0, 0. And the first point is over 1, up 1. Second point is over 2, up 4, because of the squared function there. Okay? So what I'm going to do is go over all of these, talk about them, and then we're going to put up 4 functions on that graph so we can compare them to y equals x squared. Let's get started. When A is bigger than 0, which means it's positive, then the parabola opens upward. And it means that the vertex is a minimum, never gets below that value. So this one has a positive A, it's opening upward. The vertex at 0, 0 is a minimum, never going to get lower than that. When A is less than 0, or negative, the parabola opens downward and the vertex is a maximum. Pretty straightforward. This is where it gets a little bit more complicated. When A is bigger than 1, or smaller than negative 1, that means that the parabola is going to be narrower than y equals x squared. So if we graph that parabola, it would be inside. It would be more of a narrow parabola. Okay? Now, if A is between negative 1 and positive 1, that means it's kind of a fraction. Okay? It's not good. It's going to be between negative 1 and positive 1. It might be a half, it might be a quarter, it might be 3/8, something like that. That means the parabola is going to be wider than y equals x squared. So when that one gets graphed, it's going to be wider like that. Okay? And those 2 last points are easily explained. Let's just say A is 2. Okay? If I plug in my value for x and I square it, before I get my y, I'm going to multiply that result by 2. So the y value is going to increase faster and it's going to make a narrower parabola. Okay? Let's say my A is positive 1/2. So it's not quite 1, it's less than 1. So that means when I put my value in for x and square it, before I get my y value out, I'm going to multiply it by 1/2. So the y is going to grow slower than it would normally grow in terms of y equals x squared. Okay, so now we're going to take a look in Desmos, and we're going to use that tool to show some graphs of some quadratics quite quickly. And this is a nice tool that saves you the trouble of having to generate graphs by hand. Just know that on my quizzes and tests, you may need to do that occasionally. I won't bury you in a million graph problems, but you still need to know how to generate your graph. So Desmos is a really nice tool for playing around with a lot of graphs really quickly to see what they do. But when you answer a graph question on your homework, you do want to end up with a nice graph on your page drawn out by hand. Okay, so let's jump into Desmos and play around with some quadratics. Okay, on the left here is a little line where you can enter in any kind of function that you want. So I'm going to go ahead and put in y equals x. We use the caret, which is the shift of the 2 key, or of the 6 key, and that allows me to put in my squared. And so you can see here, now I have your basic parabola. This is the y equals x squared parabola. And you notice, let's zoom in a little bit. I'm just using my wheel mouse to do that. It goes through the point 0, 0, and then it goes through 1, 1, and then it goes through 2, 4. These are basically 5 real essential points that you can use and manipulate to sketch your quadratics nice and quickly. So let's do a couple with vertex form here. Y equals, let's do parentheses x plus 2, parentheses caret 2 for squared, plus 4. Tap my enter key. Oh, Let's get that right. There's the plus. And notice how, check it out. It just graphed that parabola right away for us. And notice how this one has scooted over 2 to the left and up 4. That's where we changed the sign on the 2 for the vertex, and then we went up 4. Notice also how this parabola goes through a point that's 1 over 1 up and 1 over 1 up. We haven't changed our a term over here in the equation, so this parabola is going to have the same exact shape as y equals x squared. Let's do another one. Y equals negative parentheses x plus 3 parentheses caret 2 for the squared. Use my right arrow key to get away from the squared, and then plus 5. Let's do that. Okay, so this parabola opens downward. That was what the negative did on that one. And I moved the vertex one more to the left, so we scooted from here with that vertex over to here with that one, and I moved it one more up on the y-axis. So that's this green parabola. So you could play around with vertex form and just use this tool to kind of understand how you can translate a parabola just by shifting the vertex, by changing the HK. So let's take a look at the a term and what it does. I'm going to close out, go back to just y equals x squared. Let's take a look at a real simple one, y equals negative x squared. Now notice how that parabola looks the same, it just opens down. Okay, let's take a look at another one. How about y equals 2x squared? Whoops, I didn't type in equals. Let's get that right. There's the equals. Now notice how this is the new black parabola. It's narrower. It's increasing faster. That's what that a term is doing. You square the x that you pump into the function, and then you multiply the result by 2. So the y value is going to go twice as fast. And if that made sense, then that first point that it goes through when you put x in there should be 2. It should go through 1, 2. And check it out down here. Let's put that in the center. It goes 1 over, and now it's 2 up. And then the point for 2, when you put x in for 2, that should go through 4. Actually, 2 times 4, it should go through 8. And sure enough, it's going through 8 up there. Just to be funny, let's try something nice and big. Y equals 10x squared. And check it out. That's this little brown one. It's even more narrow. The point, when you put in x for 1 for x, you go all the way up to 10 to get your y value. So you can see as we increase the number in front of the a, as we increase a, our parabola gets narrower and narrower. Now this is for values of a that are greater than 1 or less than negative 1, okay? So let's try another one. Let's try y equals 1/2 x squared. And I'm going to get rid of some of these other ones. Let's get rid of the negative. Let's get rid of the 10x. And let's just leave our 2x in there. Okay, so our kind of rust-colored one is the y equals x squared parabola. This new blue one is much wider. It's opening wider. Let's try one more of those. Y equals negative, no, I'm sorry, y equals, let's say 1/10 of x squared. See what that parabola is doing? It's even wider, okay? So as you went over 1 on x, you should only go up 1/10 on y, and that looks about right. We could zoom in on this graph just using my wheel mouse. Here is 1 for x, and we are up here at 0.1 for y, read right off the y-axis, so that makes sense. This is another cool thing about this tool, is you can zoom in and out on your parabolas all you want so that you can get to the relevant portions of those graphs. Okay, so let's just do one more with a different a. Y equals, let's try negative 1/2 x squared. And notice how that parabola is looking a little wider and it opens down. Okay, so here's the nice thing. Let's get rid of all of these graphs. I'm just xing out of them. So I'm back to my basic parabola, my y equals x squared. Let's just throw all of this together. Y equals negative 2 parentheses x minus 4 parentheses squared plus 9. So check it out. It gave us this parabola. So there's a lot going on. We've transformed this parabola with a translation. We've moved the vertex. We've done a slide. And what we did here is we moved it 4 to the right and 9 up. So we went over 4 and up 9. And that worked out. That's our vertex right there. And then we also multiplied it by a negative 2a. So the negative inverted the parabola. So it reflected it. It opens down. And the a also changed the shape of it. So I'm sorry, the 2 changed the shape of it and made it a more narrow parabola. So when you work through your homework, you can have Desmos open on your laptop and you can think about what's going to happen to the parabola, and then you can come into Desmos and type in the equation real quickly and see if your prediction was correct. Desmos is a powerful tool. I urge you to use it when it comes to graphing. Just remember that you still have to be able to generate graphs quickly by hand. So that was a quick tour of Desmos. If you've never used this tool before, it's a really good one to become familiar with. It's also helpful in science classes whenever you're doing any kind of graphing. Otherwise, if you know Desmos, then use this opportunity to dig in deeper. There's all kinds of stuff you can do. It's a very well-featured program. You can also save files in Desmos. So if you have some key files that you want to come back to, or if you just spent a lot of time putting in a lot of graphs, just remember that you can save those files. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.